You will not see darkness when you fall into a black hole. You will see the entire future of the universe flash before your eyes, and then you will see something worse. Black holes are not theoretical. They're not abstract concepts physicists argue about in journals. They're real objects scattered throughout our galaxy. Stellar corpses so dense that they've collapsed through the fabric of space-time itself. We've photographed them. We've detected their gravitational waves. We've watched stars orbit invisible points in space, tracing elliptical paths around something that shouldn't exist, but does. And if you fell into one, you would experience something no science fiction writer has ever fully captured. Not because the physics is complicated, but because the reality is so alien, so fundamentally disconnected from human experience that language itself begins to fail. What I'm about to describe is not speculation. This is what general relativity predicts would actually happen, step by step, moment by moment, from the instant you begin falling to the moment you cease to exist in any meaningful sense. This is your final journey, the last thing you will ever experience. Let's begin.
You're in a spacecraft, approaching a supermassive black hole. Let's say it's the one at the center of our galaxy, Sagittarius A star, 4 million times the mass of our sun, 25 million kilometers across. From a distance, you see nothing, just empty space with stars in the background. But as you get closer, you start to notice something wrong with the light. The stars behind the black hole are bending. Their light curves around the invisible mass, creating a gravitational lensing effect. You see stars that should be directly behind the black hole, appearing above it, below it, on both sides. Multiple distorted images of the same star. And at the center of this cosmic funhouse mirror, there's a circle of absolute darkness. Perfectly black, perfectly round. This is the black hole's shadow, the photon sphere where light itself is trapped in orbit. You're still far enough away that you could turn around, fire your engines, escape. But you don't. You keep falling. As you get closer, the visual distortions intensify. The stars begin to smear and streak across your vision. The darkness grows larger, swallowing more of the sky. And you start to notice something strange about time. Your onboard clock is ticking normally, 1 second per second. But when you look back at the universe you left behind, everything is moving faster. The stars are aging, orbits are completing. If you had a way to watch Earth, you would see continents shifting, oceans rising and falling, civilizations rising and collapsing and fast forward. This is gravitational time dilation. The closer you get to the black hole, the slower time moves for you relative to the outside universe, and it's only going to get worse. But you haven't felt anything yet. No force, no pull. You're in free fall, and free fall feels like weightlessness, like floating. That won't last.
The event horizon is not a physical surface. It's a mathematical boundary, the point of no return. Once you cross it, not even light can escape. But here's what's strange. From your perspective, there's nothing special about crossing the event horizon. No barrier, no sensation, no warning. You might not even realize it's happened. The darkness has swallowed half the sky now. Behind you, compressed into a shrinking circle, is the entire visible universe. Every star, every galaxy, billions of years of cosmic history, all visible at once because the light from all of it is being compressed and blue-shifted as it falls toward you. And then you cross the threshold. From the outside universe's perspective, you never actually cross. Time dilation becomes so extreme near the event horizon that you appear to slow down, approaching the boundary asymptotically. To an outside observer, you would appear frozen at the event horizon forever. your image gradually redshifting into darkness as the wavelength of light from your body stretches into invisibility. But from your perspective, you cross in finite time, seconds maybe, minutes. And the moment you cross, something fundamental changes, not in what you experience, but in the structure of space-time itself. Outside a black hole, you can move freely through space, but are dragged inexorably forward through time. Inside a black hole, these roles reverse. Space becomes time-like. The singularity at the center is no longer a place ahead of you. It's a moment in your future, as inevitable as tomorrow, as inescapable as the next second. You cannot turn around. You cannot fire your engines and escape, not because you lack the power, but because the direction away from the singularity no longer exists. All paths through space-time lead forward, toward the center, toward the end. You are not falling anymore. You are moving forward through time, and that time ends at the singularity. Behind you, through the shrinking portal of the event horizon, you can still see the universe, and it's aging fast. Stars are burning through their fuel in seconds, going supernova, collapsing into neutron stars and black holes. Galaxies are colliding. The universe is evolving at an accelerating rate. If you fell into a black hole and could somehow survive long enough, you would watch the universe end. You would see the last stars burn out, the last black holes evaporate through Hawking radiation, the final heat death of everything that exists. All of it compressed into the final seconds of your fall. But you won't survive that long.
The tidal forces are starting now. Gravity follows an inverse square law. The closer you are to a massive object, the stronger the pull. And in the intense gravitational field of a black hole, the difference in gravitational force between your head and your feet becomes significant, measurable, lethal. Let's say you're falling feet first. Your feet are closer to the singularity than your head. They experience stronger gravity. They want to fall faster, and the difference in force begins to stretch you. This is spaghettification, and the name, as whimsical as it sounds, describes exactly what happens to your body. At first, it's a gentle pull, an elongation, like someone is pulling on your ankles while holding your shoulders. Uncomfortable, but not yet painful. But it accelerates exponentially. The pulling becomes stretching. Your spine elongates. Your bones separate. Your muscles tear. The connective tissue holding your body together begins to fail. And then it gets worse. Because it's not just your body being stretched lengthwise, you're also being compressed horizontally. The gravitational field is pulling you toward a single point, which means forces are squeezing you from the sides while stretching you from top to bottom. You're being transformed into a thin strand, a filament, a thread of what used to be a human being. Your bones snap, your organs rupture, your blood vessels tear apart, but your nerve endings are still intact, still firing, still sending signals to a brain that's being stretched like taffy. And you feel all of it. Every tear, every rupture, every separation of tissue that was never meant to be separated. But even this agony doesn't last long, because the stretching continues past the point where your body can maintain coherence. Your cells rupture, your molecules separate. The electromagnetic bonds holding atoms together begin to strain under tidal forces that are now operating at the molecular level. You stop being a body. You become a stream of atoms, a one-dimensional string of particles falling in single file toward the singularity. But even in this state, stretched into a molecular strand thousands of kilometers long, you haven't reached the end.
The singularity is still ahead, still in your future, and the tidal forces are still increasing.
Here's where physics becomes uncertain, where our best theories start contradicting each other. According to classical general relativity, you should fall through the event horizon smoothly, experiencing only tidal forces. The event horizon itself should be unremarkable, empty space, nothing special. But according to quantum mechanics, something else might be waiting there, something physicists call a firewall. The idea emerges from trying to reconcile general relativity with quantum mechanics. If black holes preserve information through quantum entanglement, as some theories suggest, then the event horizon might not be empty at all. It might be a wall of high-energy particles, a quantum barrier so energetic it would incinerate anything that touches it. If the firewall exists, you would never experience spaghettification. You would never fall into the black hole's interior. You would hit the event horizon and be vaporized instantly, converted into thermal radiation, your information scattered across the horizon's surface like a hologram. But if the firewall doesn't exist, you continue falling, past the horizon, toward the singularity. We don't know which is true. The math works both ways. The paradox remains unresolved. So let's assume the firewall doesn't exist. Let's assume you make it past the event horizon intact, or at least as intact as spaghettification allows. What happens next is even stranger.
You're inside now, deep inside, and the rules of reality are collapsing around you. The singularity is close, very close, and according to general relativity, it's not a point in space, it's a moment in time, a boundary where time itself ends. The tidal forces are now operating at the atomic level. Individual atoms are being stretched. Electrons are being pulled away from their nuclei. The electromagnetic forces holding matter together are losing their battle against gravity. You've stopped being atoms. You're becoming elementary particles, quarks, leptons, the fundamental constituents of matter, all falling in a line toward a point that exists 0 seconds in your future. And then, in what might be the final moment of comprehensible physics, you reach the singularity. What happens here? We don't know. General relativity predicts infinite density, infinite curvature of space-time, all the mass that ever fell into the black hole compressed into a point of 0 volume. But infinity is not a physical state. It's a sign that our equations have failed, that we're asking questions about a regime of physics we don't understand. Some theories suggest the singularity isn't a point, but a ring, or a surface, or something involving extra dimensions we can't visualize. String theory offers alternatives. Loop quantum gravity suggests space itself becomes discrete at these scales, preventing true singularities from forming. But all of these are guesses, mathematical possibilities that might describe reality or might be completely wrong. The truth is simpler and more disturbing. We don't know what happens at the singularity. We have never known. We might never know. Because there's no way to observe it, no way to send information back, no way to test our theories against reality. The singularity is the place where physics ends, where causality breaks down, where the universe stops being comprehensible. And you've just arrived there. Let's talk about what this really means. You started this journey as a human being, a collection of roughly 7 octillion atoms organized into cells, tissues, organs, thoughts, memories, consciousness. And step by step, you've been disassembled. First your body, then your cells, then your molecules, then your atoms,
then the particles that make up those atoms. At each stage, the thing that was you became less coherent, less organized, less capable of maintaining the patterns that define identity. And now, at the singularity, even the concept of particles breaks down. The very notion of things existing in space loses meaning because space-time itself has become infinitely curved. Some interpretations of quantum mechanics suggest your information might survive, that the quantum state describing every particle that made up your body is preserved somehow, encoded in the black hole's event horizon or leaked out through Hawking radiation over trillions of years. But that information wouldn't be you in any sense you'd recognize. It would be scrambled, thermalized, spread across the black hole's entire horizon, indistinguishable from random noise. Other interpretations suggest the information is destroyed, that the singularity represents a genuine end to causality, a place where the past cannot determine the future because the future doesn't exist. And then there are interpretations that suggest something even stranger, that what you're experiencing isn't an ending, but a transition, that the singularity might be a portal to another region of space-time, a white hole, a baby universe, a domain where physics operates under different rules. But all of these are just stories we tell ourselves, attempts to make sense of mathematics that describes a reality we cannot observe. The honest answer is this: we don't know what happens to you at the singularity. We don't know if you experience anything at all. We don't know if the concept of experience has any meaning in a region where time ends. You have reached the edge of knowledge, the boundary of what physics can predict, the place where even our best theories look at the equations and say, beyond here, we cannot help you.
So that's the journey. From the approach, where you watch the universe age, through the event horizon, where space becomes time, into the spaghettification, where your body is reduced to a strand of atoms, and finally to the singularity, where physics itself breaks down. This is what would actually happen if you fell into a black hole. Not a quick death, not a dramatic explosion, but a gradual, inexorable dissolution. A transformation from human to atoms to something that might not even count as existing anymore. And the truly disturbing part is that this is happening right now in our universe. Matter falls into black holes constantly. Gas clouds, asteroids, stars, entire solar systems get consumed. And every particle experiences this same journey, the same stretching, the same approach to a singularity that physics cannot describe. Black holes are not just cosmic curiosities, they're places where reality develops edges, where the universe admits there are questions it cannot answer, where the laws that govern everything else simply stop working. And perhaps that's the most unsettling realization of all. We built physics to describe reality, to predict what happens when, to give us certainty in an uncertain universe. And for the most part, it works beautifully. We can predict the orbit of planets centuries in advance. We can calculate the energy levels of atoms to 15 decimal places. But we can't tell you what happens at the center of a black hole. We can describe the journey, we can predict the tidal forces, we can calculate time dilation and gravitational lensing and all the observable effects. But when you ask what happens at the very end, when you reach the singularity itself, physics falls silent. And in that silence, you would find yourself alone, stretched beyond recognition, transformed into something that barely counts as matter anymore, approaching a boundary that might be an ending or a transition or something we don't have words for. The last thing you would experience wouldn't be darkness, it wouldn't be pain, though there would be plenty of that earlier. It wouldn't even be fear. It would be the dissolution of the very framework that allows experience to exist, the breakdown of space and time and causality, and all the structures that make it possible to say, I am experiencing this moment. You would reach the place where reality ends,
where the universe runs out of rules, where existence itself becomes a question without an answer, and we have no idea what comes next.